Today we're going to talk about clouds and how clouds are formed. Everybody knows that clouds are evaporated water that condenses, right? But a lot of people forget to point out something very important about clouds. Clouds cannot form without condensation nuclei, and I'm going to demonstrate that for you today. First, I want to talk about the air itself around us. We have water vapor everywhere in the air, outside, inside, it's all around us. The density of water vapor is roughly 0.0008 grams per centimeters cubed. That is the moist air, the water vapor itself. The air, dry air, has a density of 0.0014 grams per centimeters cubed. So what do we know about wet air versus dry air? Dry air is actually more dense. So what does that mean? If dry air is more dense than wet air, the wet air goes on top of the dry air in density? That's how that works? Exactly. So wet air is actually lighter than dry air. And that's what allows the water vapor to rise into the atmosphere. Here on the ground we have the highest pressure. And as the water vapor rises, the pressure decreases, which allows for the water vapor to actually expand. But before we get ahead of ourselves, I have this little contraption over here that I'm going to demonstrate for you how a cloud is formed. So first thing we need to do, we need to fill it up. We need to get a little water inside of here. You can see we got a little water. Alright. So with that, if I close off the air and I increase the pressure, I'm going to increase the pressure by holding this. If I increase the pressure, it's going to be clear. If I let go of the pressure, a cloud is going to form. But I don't really see that cloud forming. I think I know exactly why, because we forgot something very, very important. Condensation nuclei. What is condensation nuclei? Well, it could be anything. It could be dust, ashes, smoke particles, spider eggs. There's a bunch of different examples of condensation nuclei. For today's example, all you need is a box of wooden matches. These will work great for condensation nuclei. So I need my assistant over here to help me light this match, but first, you need to wear safety goggles, because we need to be safe. I should wear them too, but I'm a trained scientist. I'm a professional. So here we go. You're going to light a match for me. You're going to blow it out and I'm going to take the smoke. Okay, so now I have condensation nuclei inside of here. If I increase the pressure, it gets clear. If I decrease the pressure, it forms a cloud. Increase pressure, decrease pressure, cloud. So what do we know? High pressure we can associate with clear skies. Low pressure we can associate with cloudy skies. So what happens if you don't have this really cool contraption to show how clouds are formed, and you as a teacher or just a friend want to teach somebody how clouds are formed? How can you demonstrate it for them without having this really cool contraption? It's actually pretty easy with a 2-liter bottle of soda. So as we just talked about, condensation nuclei. Without condensation nuclei, nothing's going to happen. First we got to fill up the bottle with water. Just enough so that the dimples along the bottom are filled. Just close it up, shake it up just quick, get a little water vapor hopping around, water molecules floating around everywhere. And then, very important, we're going to use fire, so got to put on our safety goggles. Alright, now we got our wooden matches, which are going to work great as condensation nuclei, because like we said before, ashes, smoke particles, stuff like that are great for the water vapor to grab onto, which is exactly what condensation nuclei is. It's something that the water vapor can grab onto in order to condense. So, here we go. Condensation nuclei going into the bottle. Drop the match in. Now we squeeze, we create our high pressure system, clear skies, high pressure, release, low pressure, cloudy. High pressure, low pressure. One more time. High pressure, clear skies. Low pressure, cloudy skies. So now that we learned how clouds are formed, and we're in a college classroom, let's have a little fun with it. So this next segment is actually sponsored by Bud Light, which reminds you to drink responsibly, or enjoy responsibly. So when you open a bottle of beer, you ever notice that there's that little air up there, and you ever notice that a cloud or a little cloud starts to come out when you notice the bottle of beer, or are you too busy you just want to drink the beer right away? For those that are observant and notice, when you open a bottle of beer, a little cloud forms right there. And how does that happen? Well, if we just remember what we just talked about, condensation, what's going on? Inside here, there's gases are trapped, CO2 and water vapor. Beer is mostly water, especially this type of beer, which is pretty much purely water. It's not very much of a quality beer. But with that said, when you open this up, it's going to let the air expand, correct? So when the air expands under low pressure, you get a cloud in a glass of beer. If there is high pressure, which there is now, it will be clear. So if we open it, can you see the frost? Can you see the cloud? I'm not sure if you can, but I'm going to add a picture so that you can see exactly what it's. So what about when you pour a glass of beer? You ever notice that there's bubbles along the side? Or bubbles from the bottom? You ever notice what these bubbles are exactly? Well, those bubbles are actually dissolved carbon dioxide. And how do they form? They need a nucleation point, which could be a small crack or something like that, maybe a piece of dust or dirt inside the water. Hopefully not. Hopefully it's a small crack in the glass. But that's exactly what's happening. These bubbles, these pockets of dissolved carbon dioxide, they form and then they rise to the top because of density. Thanks for taking the time to listen to me talk about clouds. If you'd like to learn more, there's actually a great book, especially if you enjoy beer. Clouds in a Glass of Beer is a great book by Craig Boren that I suggest everyone checks out. Thanks again for your time, and I hope you enjoyed my lesson. Bye.